Hello and welcome. This video explains the process of assessing the performance of a landscape sprinkler irrigation system. The video will give those who have no previous experience of conducting such an assessment some idea of the steps involved in the process. The video will also act as a refresher for those who have experience of the process or who have previously completed a hands-on training event describing the process. The process includes collecting data and calculating the distribution uniformity, referred to as the DU percentage, of the sprinkler layout. System uniformity is important because a system with poor uniformity wastes water. Ferndale Park is approximately 12 hectares in size, and it has 3 main sporting arenas within the park area. The system has been installed in what we call hydro zones, so that the main playing areas have a different amount of water applied to them than what the passive areas get. Where I'm standing now is referred to as a passive area. You can see the pale green effect of it, and in the peak of season this is probably getting about 30 millimeters of water a week. Whereas in the background you can see the deep green of the playing area, which in the middle of summer that's probably getting 40 millimeters. And you can see around the edges of the playing area where it's dry again. So the system has been designed to allow separate watering of these hydro zones, which is an effective and efficient way of using water in landscape. The City of Canning have kindly provided a copy of the irrigation design drawing for the site. This drawing provides information about the sprinkler layout and the performance parameters of the sprinklers used. The sprinklers must be installed to provide adequate overlap, so the spacing of the sprinkler heads is important. The system must be designed to operate the sprinklers at the correct pressure for the selected nozzles. Sprinkler and nozzle selections should be shown on the design drawing. A system layout plan is not always available, but the provision of an as-constructed drawing should be a requirement for any new system. There are a wide range of sprinklers available for use in turf irrigation, and the correct selection of sprinklers for any given area is very important. This selection process is most effectively achieved through consultation between the designer and an experienced manager of the system. The heart of any irrigation system is the water supply point. Whether this is a pump unit or a connection to a pressurized supply main, the supply must have adequate flow and pressure to meet the needs of the irrigation system that it is supplying. This is the bore pump that supplies the irrigation system at Ferndale Park. The bore is pumping through this flow meter, which is below ground, and the flow meter reads out in the pump house, up into the tank where it's stored. Really it acts as a balance tank, and then the water is taken out through the other side of the tank through the irrigation pump station and out to the irrigation system. The irrigation system at today's test site is supplied with groundwater. A bore pump discharges into a storage tank, from where an irrigation pump station distributes the water to the irrigation system. The irrigation pump is controlled using a variable frequency drive, which is an effective and efficient way to meet the varying needs of the irrigation system. This pump station also includes an injection system, used to insert a soil wetting agent into the irrigation water as it leaves the pump. The wetting agent improves the effectiveness of the irrigation water applied. This results in reduced irrigation applications over the site, which equates to less water being used. The irrigation controller for the system at this site is also located in the pump shed. The irrigation water supply should always be metered, and the system water use monitored on a regular basis, usually by recording the monthly water use in kilolitres, and then by comparing this with the monthly water budget for the site. Using a meter which also shows the system flow rate provides a means of checking the rate of each irrigation station. This is a useful management tool for detecting changes in system performance and determining if further investigation is required. A meter is also a useful tool for detecting leaks in the system. For example, flow rates and water use go up if a sprinkler head has been broken off or damaged, causing a leak, and flow rates will go down if sprinkler heads are blocked or if a control valve is not opening fully. Meter readings can be taken manually or by remote, using logging devices connected to a central location using telemetry or GSM technology, or these days over the internet. Occupational health and safety is very important when working with irrigation systems. It is always advised to be sun smart, wear a hat, long sleeves, and apply sunscreen. Wear suitable footwear and high visibility vests or similar clothing. Although most irrigation controllers operate on a 24-volt supply, they may have an onboard transformer where the input power is 240 volts. Pumps operate on 240 volts or 415 volts, and some pump stations are open to the elements, so we advise that you do not ever open the closed panels. And always remember, water and electricity do not mix. Beware of snakes and spiders, which may be less than friendly if disturbed, and be mindful of nearby traffic using roads and car parks, which are adjacent to an irrigated area, by ensuring that adequate signage is in place and that all appropriate precautions are taken. If there is an irrigation plan for the site, then this should be reviewed to determine which area of the site will be used for the test. If a plan is not available, then this can be determined during a site visit. Before proceeding with the assessment of the sprinkler layout, a quick run-through of the system should be carried out to make sure that the system is in good working order for the test. This doesn't mean that everything has to be perfect, but the system should be in the condition that it would normally be in when set for automatic cycles. This preliminary test could be conducted the day before the full assessment test. After turning on each station, you should look for damaged sprinklers, faulty valves, broken pipes, and if there is any inappropriate overspray from sprinklers while operating, for example, throwing water over a roadway. This is a good opportunity to record the pump operating pressure for each station and to check that the water meter is operating. If certain things need to be fixed, then the assessment test may have to be delayed for a few days. It's always better to get things right before you start to do the assessment. Scheduling is all about how much water is applied and how frequently it is applied. Both of these functions are determined by the settings of the irrigation controller. Correct scheduling is one of the simplest ways to avoid wasting water. If there's an irrigation schedule on site, for example, inside the controller cabinet, then this should be reviewed. If a schedule is not available, then the controller settings should be reviewed and noted. This review of controller settings for each station should include reviewing days on, start times, and station run times. These settings should be checked for each program on the controller. It is recommended that the station run times are adjusted at least monthly and that the controller is turned off after a rainfall event. Summer months are when the irrigation demand is highest, and demand drops off during spring and autumn, so runtime should be adjusted accordingly. Australia has a wide variety of climatic conditions, and in some areas the irrigation system can be and should be turned off during winter. In Western Australia and some other states, local water regulations demand that sprinklers are turned off during winter. So, to summarise, you have now checked the pump station and operating pressures, you have checked the water meter and recorded readings, you have noted the controller settings, and you have reviewed the site plan and determined the test area. You are now ready to start the assessment process. You run the system for a short period to identify sprinkler locations and flag the location of each sprinkler, which may influence the test area. So we're in the pump shed, and before we turn the pumps on to start the sprinkler test, we would take a reading of the flow meter. So we have a start reading of the flow meter before we start running the pumps, and then we run the test in the field, and that might run for 10 minutes or 15 minutes. Today we're going to run it for 15 minutes, and then after the test we'll come back and read the flow on the meter and see how much water the pump has pumped. Alright, I'm just going to flag a select number of sprinklers in the area that we're going to set up the catch cups. In order to do this, we have to run the system for 5 minutes, and that lets us see where the sprinklers are, and then we'll flag the sprinklers. Being a pop-up sprinkler, of course, when it's not working, it pops down out of sight, so we need to run the sprinklers to find out where they're located. This is also a good opportunity to check the nozzle sizes installed in the sprinklers. If the nozzles are color-coded, this is a simple process. But if they are not color-coded, then it's a bit more complicated. In some cases, this can only be done by removing the nozzle, which of course can only be done when the system is turned off. Sprinkler pressures should be checked at the sprinklers in the test area by taking a reading of the pressure at the sprinkler nozzle and checking the pressure at the first and last sprinkler along the row. I'm just going to test or record the sprinkler nozzle pressure. I do that by using a pressure gauge which has this attachment on the end of it referred to as a pitot tube. So we place the pitot tube in front of the nozzle and it gives us a reading of what the pressure is at the sprinkler nozzle. So I'll just go and do that now. You can see just by looking at the sprinklers they're working at good pressure and they all appear to be operating about the same pressure. And that's just one of the visual assessments you make when you first start the system up. There would appear to be very little loss across the system. On this particular station, there are actually 2 valves operating on this station, and I know from looking at the drawing before we started the test, there's a ring main going around the area, and the solenoid valve controlling this group of sprinklers is located at this end. So by checking the pressure on this sprinkler, that's 410 kPa. So because we're nearer the valve, we would expect this one to be a little bit higher. So the first sprinkler here is 410, the furthest one was 400. So we're losing 10 kPa across the range of this particular group of sprinklers. 10 kPa is acceptable. The industry standard is 20%, which is a lot more than 10 kPa. At this point, it is a good idea to prepare a rough sketch showing sprinkler locations and possibly some other site features, so that the location and orientation of the test area can be identified again on completion of the test. Once the sprinklers have been flagged, you can now turn the pump off and proceed to set up the test. Next, we measure the sprinkler spacings. This includes measuring the distance between the sprinklers along the row and also the distance between the row. The diagonal distance between the sprinklers can also be measured, but this is not essential. We now calculate the spacing we will use for the catch cup placement within the test area and proceed to lay out the catch cups. Placement of the cups is not super critical, but a minimum of 24 cups should be used, and the cups should be placed evenly across the test site. They should also be placed within the range of the sprinklers covering the area. Cups should be placed at least a metre or so away from each sprinkler. Failure to do this will allow spray from the sprinkler to catch the cup and turn it over. Usually putting them about 500 to a metre away from the sprinkler is adequate not to get that happen. Then when the sprinkler pops up, the stream of the water is coming out, it's going above the catch cup. I'll remove the flags from the sprinklers now. We don't need them any longer. They were only ever there to mark where the sprinklers were. The system should now be set to run for at least 10 minutes, or as long as is required to get a suitable reading in the catch cups. It is best to set the run time on the automatic controller. While the system is operating, take the opportunity to observe that all sprinklers are rotating correctly and that they are completing a full 360 degrees rotation. Gear drive sprinklers, when new, usually have a rotation time of about 3 minutes. The total number of sprinkler heads operating on the station should be recorded. This information, together with nozzle size and pressure, enables us to calculate the theoretical flow rate for the station, and we can then compare it with the actual flow from the water meter reading. If sprinkler pressures have not been recorded already, this is a good opportunity to gather that information. Following completion of the test runtime and after the pump turns off, readings are taken and recorded for the amount of water collected in each cup. These cups are specially designed for the purpose of catch cups in this application. They're calibrated and they've got a tapered holding receptacle at the bottom. So you get a large catch area, about 100 mil, and that's collected in this tapered section. One side is calibrated in millilitres and the other is in millimeters. So if you want to do a quick test for what the application rate is, you've got millimeters already on there. So they're specially designed for this thing. The beauty of having a catch cup like this with the wide throat area and the narrow calibrated receptacle area is that you've only got to run the system for 10 minutes and you get a reasonable reading. Okay, so having taking all the readings, we're now ready to pack up and take the data back into the office and process the data. The last thing to do before leaving the site is to take a soil core sample. This is done to get a feel for the soil type and also to get an indication of the plant root depths. There are two key factors in determining the frequency of irrigation cycles. They are the water holding capacity of the soil type and the effective root depth of the plants. Any excess water applied by the sprinklers passes down through the root zone into the deeper soil profiles and is wasted. Finally, all equipment is collected up. You must make sure that nothing is left behind in the field and double check that the site pump station, controller and pump controls are all securely locked away. You can then return to base to assess the data and other information collected. You can now process the information collected during the site test. This includes the pump pressure, the sprinkler operating pressures and sprinkler spacings, the system flows, and the controller settings. And lastly, you can process the catch cup data to determine the distribution uniformity. In a perfectly uniform system, each of the catch cups would hold the same amount of water after the test. However, it is not possible to achieve perfect uniformity due to a number of factors which may include windy conditions, variances in sprinkler models or nozzle selection, and variances in nozzle pressures and sprinkler spacings can all contribute to lowering uniformity. In the case of this test, the DU percentage is 82%. Which is well above the industry accepted minimum of 75%. We hope that this has provided an insight to the process of assessing a sprinkler irrigation system. Some of the system checks referred to in the video may be something you can carry out yourself. You may wish to engage a qualified industry professional who can conduct an assessment of your system using industry guidelines. Or you may wish to attend a training session to develop the skills to be able to conduct your own system assessment. Information on training events is available from the Irrigation Australia Limited website. Thank you for viewing this video. We hope that the information provided will be useful and assist you in effectively managing your irrigation system, with the end result of minimizing water use wherever possible.